notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos. Section 1, number theory and computation. All 33 of those videos have been published on YouTube. Section 2, consumer arithmetic. All 12 of those videos have been published on YouTube in their entirety. Now we are at section 3, sets. This is the second of 6 videos, hopefully to be done in this month, November 2024. In December 2024, measurements. January 2025, statistics. February 2025, algebra. March 2025, relations, functions, and graphs. April 2025, geometry and trigonometry. And finally, May 2025, by mid-May, vectors and matrices. And that will cover all the objectives in this syllabus. Reminder that I have divided section 1 into 33 videos, and they have all been published on YouTube in their entirety, as I just pointed out, all 33 of those videos. They are extremely crucial since they form the foundation of the rest of the syllabus. So please make sure you look at these 33 videos and understand them well. Also, a reminder that you need to know the times tables, since calculators are not allowed in paper 1. This was section 2. All 12 of those videos have been completed and published, so that the 45 videos from sections 1 and 2 have been published on YouTube in their entirety. Now we are at section 3, which deals with sets. Here are the first 4 objectives. And then you have some more that add up to 8. And those will be all the objectives in section 8. There are not that many objectives in this section. Video 1 in this section, already published, comprises objectives 1 and 2. So that was published. We are now here, subsets video 2. Only the first 3 videos in this section will be made available in their entirety on YouTube. The other 3 will be partially available on YouTube as notification if you are subscribed to this channel. Now, if you want to see those other 3 videos in their entirety, you will be redirected to another site where a reasonable subscription fee is required. And from here on, section 4 and 5 and so on, we will follow a similar pattern where some videos in their entirety will be made available, but not all of them. So we completed those, and we are now here. Objective 3.3 lists subsets of a given set, and then you have some explanatory notes identifying the subsets as well as determining the number of subsets of a set with n elements. So there are 2 things there that we need to accomplish in this video. We said already that a subset exists only within the domain of a universal or larger set. Any part of the universal set or the larger set is called a subset. A subset is indicated by this stretched C. So consider the universal set as it made up of elements 1 to 10, whole numbers. One subset could be O and doesn't have to be named O, but we will call it O for odd numbers in that universal set, which would be 1, 3, 5, and 9. Another subset could be E, and again, you don't have to name it E, but we are just naming that to make it understandable for even numbers in that universal set, 2, 4, 6, 8, 10. A third subset could be T, which would be multiples of 3 in the universal set, 3, 6, and 9. And yet a fourth subset could be P, which would be 2, 3, 5, and 7, and those will be prime numbers in the universal set. These are all subsets within the universal set. Now, you can also have a subset of another subset. For example, let's name this one G, which is 6, and it is even numbers that are multiples of 3 from the subset E or T. So you could have a subset of another subset. So that is, G is a subset of E, which is a subset of U. But that would lead to intersection of sets, which is part of the next objective. So we will deal with that in detail in the next objective. Now consider the universal set U made up of elements 1, 2, and 3. Identifying the subsets of a universal set or a larger set. So what are the subsets here? We can list the subsets of that universal set as 1, 2, 3. So these subsets contain only one element from the universal set. There is also 1 and 2, then 1 and 3. Now, these subsets here contain 2 elements, and then there is also 2 and 3 included in that with 2 elements. Not forgetting the other 2 subsets, 1, 2, and 3, the whole universal set we said in the last video is considered a subset of the universal set. And then there is also the null set or the empty set. So if we have 3 elements in a set, its number of subsets is 8. So we are doing 2 things here together. We are identifying the subsets, and then we are counting them, the number of subsets. Now, if we had only 2 elements in the universal set U, 2 and 3, what are the subsets, all the subsets we can find here? Well, first of all, there is 2 by itself, there is 3 by itself, then there is 2 and 3, and then there is a null set. So if we have 2 elements in a set, its number of subsets is 4. So let's try that with 4 elements now and see how many subsets we will get. Before we get to that, if you find this video useful and interesting, please like and share. Like and share. You may also consider subscribing to this channel. After all, it doesn't cost you anything, and it means a lot to me. So, we are still on identifying the subset of a larger set and also determining the number of subsets if we know the number of elements. Now let's look at this universal set that has 4 elements. We can list all the subsets. First of all, A, B, C, and D. Those would be subsets with 1 element. Then we can list subsets with 2 elements. A, B, that's A, B, that's this one. Then A, C, that's that one. Then A and D, that's that. So now we could skip A and begin at B. So you have BC. You also have BD. And then finally you have CD, so far with two elements. Up here we have one element. Down here we have two elements in the subset. Now we will look at three elements in the subset. You have ABC, ABC. You have A, B, D. You also have A, C, D. You have B, C, D. Those are all the subsets with three elements. And then, of course, you have the full set, which is also considered a subset, and the null set. So with one element, four subsets. With two elements, six subsets. With three elements, four subsets. And the null set and the full set, two. If we add all of that, we get 16. Now, note for CSEC, you do not have to know how many subsets have how many elements. You do need to know the total number of subsets given the number of elements in a larger set or the universal set. So we can see that with four elements in the universal set, the number of subsets is 16. So now let's try that with five elements. A, B, C, D, and E. Let's list all the subsets that have only one element. Should be those, A, B, C, D, and E. They have only one element. Now let's list all the subsets that have two elements. Well, we have AB, we have AC, we have AD, and we have AE. That's those. Then we have BC, which is this, BD, which is that, and BE, which is this, but we're not finished yet. We also have CD, which is this, and CE, which is that, but we're not finished yet. We also have DE, and that would take care of all of the subsets with two elements. Over here, it was one. Now, let's look at three elements. ABC, that's this, ABC, ABD, ABD, and ABE, ABE. But we're not finished. We also have ACD, ACD, and ACE, ACE. We have ADE, ADE. We have BCD, BCD, and we have BCE. We have BDE, BDE. We still have more subsets with three elements. Now we will begin with C, C, D, E. And I think that will be all with three elements. Next, we will look at subsets with four elements. A, B, C, D, that's A, B, C, D. We can begin with A again. A, B, C, E. That's this one. Now you have A, B, D, E. A, C, D, E. Each of these subsets is different from the other one. There is also B, C, D, E. B, C, D, E. That's this one. And finally, you have the full set, which is, as I said, considered a subset as well, and then the null set. These two are common for all sets as subsets. So now, if we look at the number of subsets, when we have 5 elements, 5 of them have 1 element, 10 of them have 2 elements, 10 have 3 elements, 5 have 4 elements, and then of course you have these other 2 here. If you add them all up, you get 32. So with 5 elements, we can list all the subsets. They are kind of difficult to list, but we can list them with 5. 4, 3, 2. But if you go to 6, it will become more complicated. And I don't think CSEC will ask you to list all the subsets of a universal set that has 5 or more elements. What they may ask you is a particular set, a subset of the universal set. So with 5 elements, we ended up with 32 subsets. 5 elements, 32 subsets. So you understand that this could get very complicated if you have 6, 7, 8, 9, 10 elements in the universal set, if you have to write out all the subsets. However, if you are given a set and asked, is it a subset of a larger set, that would be pretty easy to do, as you can see here. Can you find all this in that? And if the answer is yes, then it is a subset. So identifying the subsets, we can do that. Now we are going to look at determining the number of subsets in a set with n elements. We can list and identify all the subsets in a universal set. But as we have seen, that depends on the number of members in the universal set, and it could get very complicated if you go beyond 4 elements in a set. Now, there is an easier and faster way to determine the maximum number of subsets if you know how many elements the universal set has. That number, as we learned before, is referred to as the cardinality of the set, and it is given the symbol n, as we saw in objective 3.1 in the last video. For example, if the set E has these members, that's 2, 4, 6, then n of E is 6, meaning the number of elements in the set E is 6. Also, if the set R has these elements, A, B, C, D, E, F, G, H, P, Q, and R, if you count them, you get n of R is 11. So R has 11 elements. The cardinality of the set R is 11. Consider what we have done so far when we look at it in a table. If you have 2 elements, as in this case here, you have 4 subsets, as we saw before. If you have 3 elements, you can get 8 subsets. If you have 4 elements, the maximum number of subsets is 16, including the complete universal set and the null set. And if you have 5 elements, the maximum number of subsets is 32. Now, what relationship is there between n, the cardinality of U, and the maximum number of subsets in U? Is there a relationship? Yes. If you consider these 2 columns, this one here and this one over here, you can see that as n increases by 1, the number of subsets double. So when you move from 2 to 3, instead of 4, you now have 8 subsets. So when this increased by 1, this here actually is multiplied by 2. And the same thing goes for 3 to 4. When 3 increases by 1 to 4, notice the number of subsets increased from 8 to 16. It's as if though you are multiplying that 8 by 2. And if we look at 4 to 5, here you have an increase of 1. This 16, if you multiply it by 2, you get 32. So it implies that there is a base of 2 with an index of n. So if the universal set had 7 elements, how many subsets can we get from that? So we put in an extra column here. When you have 2 elements, you get 4 subsets, which is 2 squared, 2 times 2. When you have 3 elements, you get 8 subsets, which is 2 to the third power, that is 2 multiplied by 2 multiplied by 2, you will get 8. With 4 elements, you get 16 subsets, that is 2 to the fourth power. 2 multiplied by itself 4 times will give 16. And for 5 elements, we got 32 subsets. So 2 to the fifth power, that is 2 multiplied by itself 5 times, will give you 32. Okay, this 7 here. I think you could follow that trend. So the rule is 2 to the nth power, where n is the number of elements in the larger set or the universal set. So now, with 7 elements, we can confidently say that the number of subsets will be 2 to the 7th power, which is 128 subsets. Now, that is very difficult to list all 128 subsets and then to count them, and very difficult and confusing. So thankfully, this is the shortcut to finding the maximum number of subsets in a larger set without having to list all the subsets and then counting them. So we will use this principle here, this here, to find the maximum number of subsets in a larger set. So let's see how well you learn this objective. We will look at 2 examples. Consider the universal set U made up of Isaac, Lucas, Amy, Sarah, and Cindy. Now, what is the maximum number of subsets that can be derived from U? Well, we count 1, 2, 3, 4, 5. We have 5 elements there. And the rule was what? The rule was 2 to the nth power, n being the number of elements. So that will be 2 to the fifth power, which will give us 32 subsets. 2 to the nth power, which is 2 to the fifth power, which gives us 32. Next, is the set G, Isaac, Sarah, and Cindy, a subset of U? Why or why not? So let's see, can we find Isaac here? Yes. Can we find Sarah up here? Yes. Can we find Cindy up there? Yes. So, answer to that is yes. And the reason is all the elements of G can be found within U. Therefore, G is a subset of U. Next part of the question, is the set B, Isaac, Lucas, Mary, and Amy, a subset of U? Why or why not? So let's see. Isaac is here. Lucas is also here. Mary, we have a problem here. Mary is not found up here. So we don't need to go any further. We can say confidently that the answer to this question is no. All the elements of B cannot be found in U. To be specific, the element Mary cannot be found in U. Therefore, B is not a subset of U. Now, is the set A, an empty set, a set of U? Why or why not? By now, you know that the empty set, the null set, as well as the complete set are subsets of any universal set. So the answer to that is yes. This is a special case called the empty set or null set. It is a subset of all sets. That's its null set. And recall also that the full set is also considered a subset of the universal set. That was review question 1. Let's look at review question 2. Consider the universal set U that has elements P, Q, R, S, T, and U. Now, what is the maximum number of subsets that can be derived from U? 2, 4, 6. Well, we have 6 elements there. And by now, you know how to deal with that. 2 to the nth power. And so we come up with 2 to the 6th power, that is 2 multiplied by itself 6 times, will give us 64. 2 to the nth power, 2 to the 6th power, because you have 6 elements, and that gives 64. Now, is the set X, P, Q, R, S, and Y a subset of U? Why or why not? Okay, let's see. P is there. Q is up there. R is up there. S is up there. Problem here though with Y. Y is not up here. So the answer to that is no. All the elements of X cannot be found in U. Therefore, X is not a subset of U. Next question. Is the set R, S, Q, and T a subset of U? Why or why not? So you have S here, this is S. You have Q here, that's Q. And you also have P here. So the answer is yes. All the elements of R can be found in U. R is a subset of U. Now, is the set A, S, U, P, R, T, Q a subset of U? Why or why not? So let's see. S here is there. U here is up there. P is here. R is there. T is also here. And Q is there. Well, that's the whole set. But remember, we said the whole set is a subset of the universal set. And even though they are not in the order as up here, all of them are still there. So the answer is yes. All the elements of A can be found in U. Therefore, A is a subset of U. So we just completed this objective here, objective 3. List subsets of a given set and also determine the number of subsets of a set with n elements. That is 2 to the nth power. And that brings us to the end of this objective. List subsets of a given set. So it brings us to the end of video 2 based on objective 3 in section 3.